Welcome to this video. So in this video, we are going to look at questions on compounds of carbon and bonding. Okay, so the first question they're saying, organic compounds are considered as compounds of carbon. Provide an explanation to account for the validity of such a statement. So here, we're going to say, okay, carbon is the chief element of all organic compounds. No wonder all organic compounds are considered as what? Compounds of carbon. So this is the answer here. Okay, so if no carbon is present in a compound, then the compound is not an organic compound. As simple as that. Okay, so because of this, the carbon will form the spinal cord or simply the backbone of all organic compounds. Okay, so that's the reason why organic compounds are considered as compounds of carbon. Why? Because carbon is the chief or the main element of all organic compounds. Okay, so the second question they're saying, is carbon a metal or a non-metal? Provide an account of support to your answer. Okay, or provide an account to support your answer. So carbon is actually a non-metal. Okay, so why is it a non-metal? Because of the nature of bonds that it forms. So carbon forms covalent bonds. So in covalent bonds, there's a sharing of electrons, and sharing of electrons is a characteristic of non-metals. Okay, so this carbon sits in group 4 of the periodic table, and it forms bonds mainly through covalent bonding, which is just the sharing. Okay, so it does not show any metallic behavior or ionic bonding. It does not show those types of bonds. No wonder we are calling carbon as a what? A non-metal. Okay, so carbon also has the ability to combine with itself one, okay, with metals and with non-metals. All right, so that's all on question 1. Question 2. Using sketches, show the formation of sigma and pi bonds. Okay, so before we can even show the sketches, we have to define what a pi bond is. Okay, so here I was writing and said a sigma bond, okay, indicated by this symbol. Okay, sigma bonds are a type of covalent bond formed by the direct end-to-end overlap of atomic orbitals. Okay, so for you to form a sigma bond or a pi bond, you need what we call as atomic orbitals. So we have two types. Okay, we have the S, which is in form of an oval or a circle, and then we have a pi bond that looks something like this. Okay, it can also be something like this. So this is vertically, this is horizontal. So this is a pi. This is a p orbital. Okay, and then this is an s orbital. So for you to form sigma bond or pi bond, there should be interaction between these orbitals. Okay, so the sigma bond is formed in 3 ways. Okay, it can either be head-to-head interaction of 2 s orbitals, or it can be head-to-head interaction of 2 p orbitals, or it can be head-to-head interaction of 1 s orbital and 1 p orbital. Okay, so the first scenario where you're forming a sigma bond is when s and s overlap. Okay, so the bond that will be formed here will be a sigma bond. Okay, what about if an S overlaps with a P? The bond that will be formed there will also be a sigma bond. Okay, and then also when a P orbital, okay, overlaps with itself head-on like this, the bond that is there is going to be formed, is going to be called a sigma bond. Okay, so you can see that all these interactions are head-to-head. Okay, so if there's a head-to-head interaction of 2 orbitals, okay, it can either be the P and the P, S and S, or the S and the P, like in this form, this is the S, this is the P, you're going to form what we call as a sigma bond. Okay, so these are the sketches that they want. So you show these. And then how are we going to form the pi bonds? Okay, so the pi bonds form through the sideways overlap of parallel p orbitals. Okay, so I can have one p orbital like that in red, and then I have another one like that in blue. So the bond that they're going to form here and there is what we call as the pi bond, or it can be in horizontal form like this, okay, and then like that. So the bond that is going to form there and there, we're going to call it as a pi bond. So the pi bond form as a result of the sideways overlap of the p orbitals. And note that the pi bonds can only be formed, okay, by the interaction of the p bonds. They are different from the sigma bond. The sigma bond, they can be formed by the pi and as well as the um, the sigma bonds, they can be formed by the p orbitals. Okay, they can also be formed by the s orbitals or a combination of both. But for the pi bonds, they can only be formed by a sideways interaction of the p orbitals, as we have seen here or there. Okay, so we've answered question A. Question B. What kind of N-to-N bond do you think is present in the nitrogen molecule? Okay, so in the nitrogen molecule, you're going to find a triple bond. So it's going to be like this. That's the type of bond that you're going to find. So in this triple bond, you have one sigma bond and two pi bonds like that. Okay, so that's what you have there. So if we were to draw, okay, this structure for this bond, okay, of the nitrogen, it would look something like this. So this is my nitrogen, and then I have another nitrogen. Okay, so I'm going to have some orbitals that come like this. They're going to bond like that. Okay, and then there will be some other orbitals that are going in this sideways direction like this. And then another orbital that goes in those directions like this. Okay, so you can see head-on interaction here. So here, I'm going to form the sigma bond. Okay, and then the interaction of this green orbital with this green orbital is going to form a pi bond. So the first pi bond. And then the interaction of this yellow orbital and these yellow orbitals will also form a pi bond. No wonder we said in the triple bond, we have one sigma and two pi bonds. So I've shown you how those things form. Okay, question 3 is just purely on definitions. They're saying define the following terms as they are used in chemistry. So the first one is ionic bond. The second one is covalent bond. Okay, so what is an ionic bond? So we have two ways in which you can define it. So the first one, I was saying an ionic bond, okay, is a bond that is formed by donation and acceptance of electrons to give oppositely charged ions held together by electrostatic attraction. So a good example is the sodium ion and the chlorine ion. Okay, so this one is positive, this one is negative. So they will be attracted to each other like that. They're going to form an ionic bond. Or the other definition that is very easy, you can say an ionic bond is the shortest distance between two oppositely charged what? Ions. Okay, and then how do we define a covalent bond? So a covalent bond is the bond, okay, a covalent bond is a bond formed by the sharing of valence electrons. Okay, so covalent bonds are the most useful or the most important in organic chemistry. Okay, so to form all the compounds that you're going to be talking about in organic chemistry, you're going to be using covalent bonds. Okay, for the C to bind to itself, that's a covalent bond. So covalent bonds are very important, but they have just a simple definition here. Bonds that are formed by sharing the valence electrons uh, between two atoms. Okay. Question 4, they're saying explain the term hydrogen bond. Okay, so it's just a simple definition. You say a hydrogen bond is an electrostatic attraction between a hydrogen atom bonded to an electronegative donor, okay, which will be denoted by Dn, the donor, and an acceptor atom indicated by AC bearing a lone pair. Okay, so what we are going to do here to illustrate this is that I have this electronegative atom that I'm calling the donor that is bonded to the hydrogen, right? Okay, and then I also have an acceptor atom, okay, an acceptor atom AC that has a lone pair of electrons like that. So you know that this hydrogen here, okay, it's partially positive, right? And then this lone pair here will be negative. So the positive of this hydrogen and the negative charges of the lone pair, they're going to be attracting each other. Okay, so what they end up forming is the hydrogen bond. So you're going to have the donor bonded to the hydrogen, and then this hydrogen will be hydrogen bonded to the acceptor like that. Okay, so it will mean your form here, this dotted a bond here is called the hydrogen what? Bond. So that's what the hydrogen bond is. Okay, and then B, they're saying using sketches show how hydrogen bonding takes place, I mean. Okay, so this is what I was showing here. So you have a donor attached to a hydrogen, okay, and then if nearby this hydrogen there's an electron, I mean there's an acceptor atom. An acceptor ion simply meaning it is accepting the positive charges. So this acceptor ion has to have lone pairs like that. Okay. And then when these lone pairs and the hydrogen interact through electrostatic forces, they're going to form hydrogen bonding. So I have a specific example that I can give. Okay. For example, the hydrogen bonding in water. So in water, I can have H and then oxygen and then H. So this oxygen here is electronegative and it has a lone pair on it like this. Okay, and then I'm going to say plus another water molecule with the same lone pair like that. Okay, so what happens here is that these electrons here will be attracted to this hydrogen atom here. So what will end up happening is this now. So we're going to have H, O, H, and then this lone pair and the hydrogen will interact through a hydrogen bond. So I'll denote it by dotted lines like that. Then H, and then this one still has the lone pair there, and then H. So if there's another water molecule somewhere here, okay, if there's another water molecule somewhere here, this hydrogen can also interact with this to form hydrogen bonding. So that's how in water, there's always hydrogen bonds because they form like this. So this one will form this one will form with another water just like that. So what we are forming there is what we are calling as hydrogen bonds. Okay? So that's how we can show it using sketches. Okay? So this one was a general form, and then this one is a specific example. Okay, so that is that. Let's look at the next question. So the next question now is just an application. So they're saying provide an example of a biochemical molecule type, okay, in which hydrogen bond is likely to be found. So by biochemical molecule type, they mean the classification of those biomolecules like the proteins, okay, the carbohydrates, the fats or the fatty acids, okay? The nucleic acids, that's what they mean by biochemical molecule type. So provide an example in which hydrogen bonding is likely to be found. So the example that I gave here is in proteins or DNA. So in proteins, okay, you realize that we're going to find a lot of hydrogen bonds. So the hydrogen bonds there will be stabilizing the structure of the what? Of the proteins. So in the primary structure, secondary structure, we'll be finding these what? These hydrogen bonds. Okay, even in the tertiary structure. So a good example, just say proteins here. So I said proteins there. Okay, and then here they're saying provide a reason, okay, for the presence of hydrogen bonds in such a biochemical what? Molecule. Okay, so the reason is this one that I wrote down. So in short, why do we find hydrogen bonding in proteins? Okay, it's for the stabilizing, okay, of the structure. But if you want to be more specific, you can write this definition that I wrote here, the reason. Okay, so you can say the reason is that they contain many electronegative atoms, okay, with lone pairs and polar X to H groups. So, okay, the donor to accept the interactions form and strongly influence their structure and also their what? Biological function. Okay, then you'll be done. So we are done with this tutorial sheet. Okay, that was on what was this topic? To compounds of carbon and bonding. Okay, so next we are going to look at okay, so I didn't finish. Okay, I thought this was the last question. Okay, let's do the last question now. So the last question here they're saying, okay, the last question here they're saying, um, write the first two reactions in organic chemistry to be carried out in a lab. Okay, so very important. You should master these uh, reactions because they're going to come. Okay, they're just going to ask you write the first two reactions in organic chemistry. So the first reaction was the alkaline treatment of animal fat, okay, which produced soap, I mean, and glycerin. And then from that soap, okay, they were able to separate it into what? Fatty acids. So the reaction goes like this. So you have animal fat. So I'll just write AF, okay, and then you react it in alkaline water. So there's water here, or maybe the water should be down. Okay, so there's water here, and then you add the sodium hydroxide to make it alkaline, basic. So when they got this animal fat reacted with alkaline water, they produced soap plus glycerin. Okay, so this glycerin has the formula C3H8O3. Okay, and then from here they got the soap. This soap, they acidified it. So here you can write acidification. Okay, they acidified it in uh, water, okay, or in with uh, hydrogen ions, because this H3O plus the same as hydrogen ions. So they acidified this soap and then it's separated, okay, or it formed the fatty acids. So this was the first reaction in organic chemistry. Okay, so they first observed the transformation of one carbon compound into others after separation from what? From the soap. So here you're just separating the fatty acids that are here from the soap by acidifying the soap, so you just get fatty acids. Okay, and then what was the second equation or second reaction, okay, in the history of organic chemistry? So the second one was the laboratory synthesis of urea. Okay, so how did they synthesize urea? Okay, they treated lead cyanide with ammonium hydroxide. Okay, so lead cyanide, when you write it in formula form, it is something like this. So there should be a C here, then O2. So this is lead cyanide. So they treated this with ammonium hydroxide. So ammonium hydroxide is NH4OH. Okay, and then once they did this, they formed what we called isocyanate. So isocyanate is CHNO, and then plus they got ammonia, plus they got lead hydroxide. Okay, so this is what they got. So from this now, okay, they needed to react the isocyanate with ammonia to form what they wanted, which was the what? The urea. Okay, so this was the laboratory synthesis of urea. So they got this one here. So this one here is called isocyanate. So they got the isocyanate, okay, reacted it with ammonia or in ammonia, and then we are able to come up with what they wanted, which is what? Urea. Okay, so this is urea. So these are the first two chemical reactions to happen in organic chemistry. So just write this the way I've written it in case it comes, even this one the way I've written it. Then you get the correct, you get the question correct. Right, so we are done now. So in the next video, we'll be talking about orbital hybridization and molecular structures. Okay, so I got these questions from uh, a tutorial manual on organic chemistry. This is the manual here, and I've solved all the other questions. Okay, so I was solving tutorial sheet 1, which is on compound of organic um, compounds and bonding whatsoever. Okay, so we've solved this one. Okay, so if you'd like to access the videos where I was explaining the answers to all these other tutorial sheets, like this is tutorial sheet 2, okay, you are free to register with us. Okay, also all these questions here, I've solved them already, and they are on our website and our app. So the best or the good thing about our app is that you can download the videos, okay, and then you can even watch offline in your blankets. Okay, you can download the videos on the app and then you watch offline anytime. Okay, so if you go maybe to school where there's Wi-Fi, you can download the videos in advance, and then when you go to your boarding house or your room, you can start watching them offline. So all these questions here, we've actually answered them, and the videos are there on our website and our app. Okay, so those who'd like to register with us, please feel free. So you can text the number in the description below here, okay? Or you can simply just go to the website. So there's the link there for the website and the link also for the app. So you choose whatever you want. So we've solved all these questions here, and the videos are waiting for you on the website. Okay, so thank you so much for watching. This has been Tutor Post Solutions. Until next time.